Sean.
Hey everyone, welcome to Graph Time with Sara and Sean. I'm Sara.
And I'm Sean. Sara and I make games, animations, and interactions in the Desmos graphing calculator.
Today it's October and we're going to do some spooky graphing today. So we're going to get started with building a web and then we'll get to see a little spider. So if spiders aren't your thing, then this one's going to be really cute and maybe you'll love them after this. We're just going to get to graphing, making a spider web. It's almost like if we had like a stop sign or octagon or something and a bunch of them, then we kind of start getting this web shape. One way that I can think about this is by starting with the circle and trying to get points along my circle. A point along a circle, the x value of like, if we think about angles, if we're going all the way around, the x value of an angle is cosine, and the y value at an angle is the sine of an angle. So let's see what that looks like. Let's see what we mean. I'm going to make a variable, and I'm going to call my variable angle.
If you are rebellious, if you're like a bad boy, bad girl grapher, you can put sine first and cosine second, and it still works. Pretty much
That's
the
true.
same.
That is true. As it goes along the circle, as my angle increases, right there, it stops. It looks like it goes all the way around right here. We're at around this number 6 point something, which happens to be 2 pi. That's like a full rotation along the circle. So I'm going to make this go to 2 pi. And now we can see cosine of an angle, comma, sine of an angle. We have this point. It can move all the way around the circle.
Writing cosine and sine this way with an angle will give us 1 point along this circle.
Exactly.
And it's just kind of like a clever thing to do. It's like you're going to take points along that circle, but then when you connect them, you're not going to have a circle anymore. You're going to have a 7-sided or 6-sided shape.
So instead of one angle, I want to find 7 angles. I'm just picking 7. Let's say we want a 7-sided polygon. And ideally, these angles are equally spaced. One way I can do that is by chopping everything up into sevenths. So maybe I start at 0. I have 0 sevenths, and then 1/7, 2 sevenths, 3 sevenths. I could do ... but I'm just gonna type them all out.
Yeah, it feels helpful just to see them in this case.
I'm noticing something about like how my angles go from 0 to 2 pi here, but here they're going from 0 to 6/7. What do you think I should do, Sean? How can I make the angles work how I want them to?
Well, yeah, okay, so we want the whole thing to be 2 pi. So I think if you just multiply that all by 2 pi, then we'll get kind of like equal spacing along 2 pi.
And I'm going to see what happens if we replace our single angle with the entire list of angles. Are you ready?
I'm ready.
Ooh,
Nice.
look at that.
Awesome.
Okay, so now that I have these equally spaced points, I can connect all of those points with the polygon feature in the calculator. So I can just type polygon, and there we go. I'm going to turn off this circle, and I do not want the fill in my spider web, so I'm going to turn off the fill. Okay, great. I'm going to go ahead and turn off the background. Okay. And I think I want a few of these. So I'm going to duplicate this. I'll do 2 for now. And if I want to make this bigger, I can scale it by multiplying all the points by a number. So if I want it 2 times bigger, I can multiply this by 2.
Yeah, multiplying is always like a stretching kind of like function. So it's always going to stretch it in some way or another when you multiply somewhere.
Let's do that again. Ooh, we got a
Nice.
third one. Let's do one more. Nice. Okay, how does this feel?
That feels great.
Okay, cool.
Starting to look like a web.
It's missing a few things. So I think what's missing to make it feel very web-like is some lines that are going through like this middle point to the very outer polygon. So I know like this most recent polygon that I drew, it came from these points here. There are my points. And I wanted all of those points to connect to 0, comma 0. Let's see. So I think what I can do is like create a polygon. Um,
Whoa.
I know. I honestly wish I could explain better why. We're Sean and I have been talking about this.
The 4 cosine angle sine angle, that's like all of the outside points.
Yeah.
And so what you're doing with that is you're connecting all of them to 0.
Yeah. I'm connecting all of these outside points to 0, comma 0.
Cool. Awesome.
Okay.
You make it
So
look easy, Sarah.
So what I'm gonna do now that we have this spider web is I could put all of these things into a folder and I'm gonna send it over to Sean, um, who is gonna make a spider.
All right. So I cheated a little bit. I have a spider prepared. Again, we use a lot of images in the graphing calculator because they run pretty fast. And they also like it's a little bit easier to make them look nicer as well. A neat thing that you can do in the graphing calculator is if you have a link to another graph, you can paste it into a line in your graph in order to kind of like merge them together. So I have Sarah's graph. I'm just going to go in this expression list. I have the link copied. I'm just going to paste it, and there's the web. But I want so the spider's made up of 4 images. I'll talk about that in a minute so you can understand why I've done that. But first, I have to put the spider in front of the thing by unchecking this box. So if you shift click or long press here, you can turn off place behind graphs, and then your spider or your images will show up on top. I pretty much always do that whenever I bring an image in to the graphing calculator. So first thing I would do is maybe change the size of our spider. He is enormous on this web. So let's change the size, maybe like 2. So so I want to keep the ratio between these so it doesn't start looking strange. So I can do that. Since this is 10 and I'm making it just like W spider, I can make this 0.44 W spider. I'm just like moving this decimal place over. So I'm just going to do that to all the images. Oh, except
Oh,
this
you
one.
forgot a W
Uh-oh.
spider.
Oh,
Oh.
yeah. See, it looks smushed. See, we don't want to get the ratio off or we smush our poor spider. This image is a little bit different. The rest are in the same frame, but I kept the eyes separate. So I'm just going to kind of rescale these manually.
Sean, I'm seeing that you have a lot of images here for the spider. Why?
Let me get rid of the web for a second just so we can look at each of these images. So basically, I have this spider in different parts, and that's because I want to make this spider move. I want the legs to move separate from the body. So I have one set of legs. Now, I might do this if I were to really try to make this look nice. I might use like more sets of pieces of legs. So I might use like 2 legs or like individual legs, but to keep it a little bit simple, we're just going to use 2 sets of legs. We have kind of like alternating legs on each of these images. And I just made that when editing the images so that I could do them separately. Because if we start like wiggling one of these sets, it's going to start looking like the spider is moving. So we have the body. So the body will probably stay still or maybe just move like a little bit. And the legs will be kind of wiggling alternatively as we move around. And then I just thought like maybe it would be fun to make the spider look around later. We'll see if we have time. But so I need a point for my spider. So I'm going to call P spider. And I'll put my web back on just for fun. So we've got P spider. I'm just going to put it in every image. Oh, we got to add that one in. Okay, I'm going to put it in every image. And then I can move the whole spider at once. Now, there's a pretty cool trick when you want to make something move. You can use a bunch of animation timers to like individually animate it as you want. But if instead you make how the legs move based on something like the X position or the Y position, then if you move it, it'll just automatically move its legs. So we'll see that in a second.
Yeah,
Okay,
so like when the X position is changing, something about the legs will also be changing.
exactly. If we want to make that happen, basically what I want to do is like, so if I have an angle for one of the sets of legs and I just kind of wiggle it around, I'm gonna make two angles, one for the angle legs left. Is that the left one? I don't know. Well, actually, I guess it's not
Oh
left and
yeah, it's
right.
left and right.
We'll
Both,
say
both.
angle leg one. Like if you remember, like sine of x is just like waves, so it just like repeats over and over again. So if I want to make these legs kind of like wiggle back and forth, then I can make them follow a sine wave and they'll just kind of like repeat a little wiggling motion. And if I just, put some numbers in front to scale it how I want, it'll wiggle hopefully just the right way. So first thing we need to do is make what I want this to do is as I kind of drag this like up and down the screen, I want it to change. So Sarah, what's like changing when I move the spider up and down the screen?
It looks like the Y coordinate is changing the most. Yeah, when you're moving it up
Yes.
and down.
So as I move it down up and down the screen, the y coordinate changes the most. So I can like access that y coordinate by typing like p spider dot y, and that'll show just the y coordinate. And then if we just put this as the angle leg one,
It's gonna be crazy.
it's gonna, it's gonna shake back and forth based on the y value. But it's actually just going to kind of rotate fully in a circle, because just as y gets bigger and bigger, the angle gets bigger and bigger. So it just like spin like a helicopter
Mhm.
spider. Uh, Honestly, that's like kind of fun. Maybe we'll just wee. That's not how a spider moves, but it's pretty fun. Okay, so we want it to be more like this, up and down and up and down and up and down. So that's why we're going to use sine. So if I wrap this in a sine,
A special thing about sine is like no matter how big what's like inside of sine, it's gonna give us like small little outputs, like between whatever numbers we want.
yeah. So usually sine is going to go between -1 and 1. Well, I guess always it's going to go between -1 and 1. So no matter what I put, whoa, chill spider. But 1 is a big angle, so these are going like crazy. So it's kind of doing what I want, but just like way too much. So all I need to do is take these angles and reduce how much I'm doing it by. Just scale it down. So maybe 0.1. So now as I drag it, okay. I think I want it to be a little, so this is a little tricky. I think I want it to be a little less, but I also want it to be faster.
Yeah.
So basically we want changing the Y to have more of an effect. So if we go
Yeah.
right to where that Y is, we want it to have more of an effect. We just need
Let's
to
double it
multiply.
or
Yeah,
something.
double it. Okay.
Ooh,
I
that's
think
pretty
you
good.
I think even more. Let's go
Oh my gosh, that's so fun.
maybe even more.
Oh my
Oh,
gosh,
there we
that's
go.
actually kind of spooky. I don't know about very Halloweeny.
Oh, there we go. Really, really kind of skittering now. Okay, nice. So if you were to do some kind of animation timer where this moved and you were to change the Y, it's just gonna automatically do the legs. And then the really neat thing is if you make it move faster, the legs are gonna move faster because it's based on how high it is. I kind of want to see like less, more. So some numbers in here. In between. Oh, I think I
That
got
looks
it.
really good.
Yeah, that feels good to me. Okay. This blue point's annoying me. So a neat thing that we can do is if you want, you can make an image draggable without seeing the movable point. That's just kind of in the way. It's going to be in the way no matter what I do. But if you take the kind of foremost image, oh, I can't put that behind. Well, hopefully this works. If you take the kind of foremost image and you make it draggable, so the body's the one that's kind of most in the front, and make it draggable, that actually just is going to do it. Now I can just drag the spider. It probably won't work if I grab the eyeball, but we just won't do that. There you go. That's awesome.
It is awesome. Okay, but what if you drag it left to right?
Yeah, it's not gonna really move. Sometimes it's a little tricky to do both. We could just put plus X in here, but it can get a little weird because they can cancel each other out.
Oh, like if it's moving diagonally along the
Y-
line y equals negative
y-
x or something?
Yeah, so this will work great if I like move it up and down, or I move it left and right, or I move it diagonally this way. Well, if I move it diagonally this way, it goes like twice as fast. And if I move
Oh.
it diagonally this way, it doesn't move at all because
Oh.
the x's are getting more negative and the y's are getting more positive, and they cancel each other out.
Oh, that's so interesting.
Yeah, I don't know. I feel like I've always struggled a little bit with this. You always end up with a little bit of weirdness. I usually figure it out in the end. Maybe we take the absolute value. It'll mostly work. It gets a little weird near 0,
Oh, that's so interesting.
but
Okay, I like the first one that you had.
just with the y.
Yeah, I liked the y, just the y.
Yeah, and then yeah, it feels like the spider would move this way. Like it would be a little bit weird to
Yeah.
move just left and right. Anyway, nice. I'm gonna go in and make the web a little less.
Yeah.
You can. I'm just gonna change like kind of the line thickness here.
Yeah, that's a great idea. Okay, I have a crazy idea.
You know
I
I
don't know
love crazy
I don't
ideas.
know if it's gonna work or not. I kind of want that, like, as it goes up, I kinda want the, like, width of the legs to get smaller. Is that possible? I'm saying as it wiggles, like, we go between small leg, long leg to kinda give this effect
Interesting.
of it's like
Oh, okay. I'm picking up what you're putting down. This is the width of the legs. So if we like took this and multiplied it by 0.8, the legs would get skinnier.
yeah,
And if you multiplied it by like 1.2, the legs would get longer.
yeah,
So what you're saying is like also part of this walking animation, maybe the legs
yeah,
get a little bigger and smaller. I'm excited by this. So let's say like we're gonna start this at like one hole, and
mhm,
then we're gonna add. So we want the sign again in order
yeah,
to like keep doing like a repeating thing.
yeah, it'll get bigger and then smaller and bigger and smaller.
Yeah. So this is like we'll make it like a little bit bigger, and then we'll put as the y value changes because we're sort of using this y value to make everything move. So this will so it's hard to read this whole thing in here, but I can actually take it out. So like we'll do width of the leg, and then we'll put this here with like 1 maybe. Okay, so now we can see it. So this is saying I want to take I want to increase the width of the leg, and I will decrease it. Kind of like repeats on a cycle, like get 1.1 bigger, get
Yeah.
0.1 smaller. I'm just gonna go. I don't know what's gonna happen. Let's do it for the second leg too. Just get the whole reveal in here. But like probably the opposite, so that it's like out of cycle.
Oh, okay. Yes.
And then we'll put that for both of the legs. And oh, interesting. Okay. I think that's gonna be good, but we have to we probably want it to be on the same like frequency as
Oh, so it needs a 5 in front as well?
yeah, it might be wrong to do that actually, but we'll see. It'll be we can go from here.
Whoa!
I like that, but I think it's just too much. We just want to do less, like maybe 0 point or 0.03 for these. So it just happens a little bit less. Maybe out honestly, maybe out of cycle. Oh,
Wow.
That
It does
felt creepy to me.
falling.
Oh my gosh, that that's good. I like that.
Yeah, that is really good.
Yeah, it turns out it felt a little more fun to be a little bit out of cycle with the way the links were moving. Oh, that is getting creepy. I love it. We'll put that graph in the comments for you to check out.
I'm usually very afraid of spiders, but for the sake of doing some graphing today and Sean making this very cute fuzzy spider, I feel like I conquered a fear, and you can conquer fears too of spiders and of other things too.
Be brave.
Be brave. That's today's wisdom, is to be brave. Thanks for watching. Sean, thanks for making this incredible wiggly spider, and we will see you next time.
Graph time, laugh time, math time, graph time. Let's get creative and play with some graphs. Come round the table and we'll do the math. Graph time! With Sarah and Sean.